Today's FortiNAC recording, we'll talk about how to control different device types and their network access. And the example today is going to focus on a PLC controller. I have one of those in my network plugged into port 4 of my Cisco switch. And we can see that it's a PLC device type of vendor. I can see the host name, I see the operating system, I see the VLAN that the device is in currently, and its IP address. Now, how did I get there? How did that happen? One of the things that I can do is, if I have a known PLC device on my network, I can run Nmap. Nmap's built into FortiNAC. It's a light Nmap scan, so generally it's usually okay to run on PLC devices. And through running this Nmap scan, I'm going to find some additional information about this device. This particular device has port TCP 2000 open and port 5060 TCP open. And through DHCP fingerprinting, I also know that it's a Chrome device. So this information is very helpful in designing a PLC device profiling rule. Now, part of the process is defining your device type, and there's a couple different ways to do that, but we'll go straight to the device profiling rule with that information that we know from the Nmap scan. Through this process, I created a PLC device profile. It's enabled, so it works. And the way that I have it set up in this particular method is, when I find a PLC device on the network, I will automatically register it versus manually registering, having somebody approve it. I'm going to assign it the device type PLC that has a little PLC icon that I created. And I'm going to add it to a group called PLC devices. And then if I'm concerned about using MAC addresses for identification, which I should be, I'm going to check this box and have it confirm the device rule on connect, which really means when the PLC device is disconnected from the network and then it reconnects to the network, we are confirming that it's still a PLC device. If we're in a high secure area, we can also disable that device if the identity changes and it no longer looks like a PLC device, even though it has the same MAC address. Now, how to identify a PLC device on the network? Again, using some of the information that I picked up from the Nmap scan, I have a vendor code from the MAC address field. This could be a code or it could be a name. I could add other different device types in here. So if I have a Schneider Electric PLC device, I could add that in here as well. It would apply to both. This is an OR setting. TCP ports from the Nmap scan were open, 2000 and 5060. And from DHCP fingerprinting, I also picked up the Chrome OS operating system. So these three matches tells me that it's one of the PLC devices. And we have other ways, other methods that we can add, whether it's S&MP strings, SSH access, a particular range of IP addresses that we can use in the device profiling rules methods. This is what I used in my demo network. So I have that device and I run that against all of the rogue devices in my network to find all of the PCL devices. Now I only have one. I can see the queue size. It's going through the network looking for existing. And the nice thing is, if I added 10 more tomorrow, we would automatically profile those devices and assign the icons, assuming they matched all of the methods in here. Now let's go back and look at the configuration of the network ports, talk about some of these things, and show you how it actually works. And then we'll go into a little bit more detail on how we built this process out. So as you can see, I have a camera on port 7, and then it's in VLAN 120. I have a PLC device in port 4, and it's in VLAN 127. And I have a Raspberry Pi in port 1, and it's in VLAN 199. So if somebody decided to disconnect those devices or just do some rewiring, and I disconnected the cables from the switch, and I started plugging those cables back into the switch, but maybe I didn't remember where I connected those devices. I'm going to let FortiNAC do the automation for me. And we can see that the PLC device came into the network, and it's going to show up on this port, and it's going to change it into port 127. The camera has already arrived on port 1. It's in port 1 or VLAN 120. The Raspberry Pi is in VLAN 199. So everything happened through an automated process. I have the same thing on a FortiSwitch. So if I take that same PLC device and plugged it into port 1 of my FortiSwitch device, so this is a FortiSwitch that's in FortiLink mode, I can watch that same process happen. And I just connected it in. There is a process that starts. We'll see the device show up on the port, and then we'll see that it's in VLAN 127, same as we had on the Cisco switch. So the process is vendor agnostic, so we can see that that device icon showed up for the PLC. We can see the VLAN that it was assigned is 127, and that information is all handled by the automation tools that we have set up within FortiNAC. So let's go talk about NAC policies and how we actually applied VLAN 127 to this PLC device on both the Cisco switch and the FortiSwitch. In this process, I have policy configuration. There's a couple pieces in here to set up. Part of it is, how do I identify all of the PLC devices in my network? So in the device profiling rule, we created a device called device type PLC. This is what gave it the cool little PLC device icon. So all I did was added this into the filter to be able to say, look into the database and show me all the device types called PLC. So very simple. I picked that one option, clicked OK. So anywhere they connect wireless, wired, any groups that they belong to, as long as it's a device type called PLC, that'll be part of our network policy. The other part of the network policy is logical networks. So I have a manufacturing logical network. It's VLAN 127 in most cases, but it's a logical network called manufacturing. So my network access policy is made up of those two pieces. I have a PLC manufacturing policy. It uses that PLC device type that we just saw for the host profiling. So that's in here. And then I have the NAC configuration is when that PLC device connects to the network, then our action is put that device into what we call the logical network manufacturing. So if I take that concept back to the Cisco switch, if I come back into my topology view and I look at the configuration of the Cisco switch, in this configuration I have model config, so all of our devices, everything in the system has a model config, and in this model config I have a manufacturing logical network, and I tell that manufacturing logical network that goes into the manufacturing VLAN, so I have a list of all the VLANs in the system, or if I knew it by VLAN ID, then I could say it's VLAN 127. So I have that set up in here, so when a manufacturing device, in this case a PLC, connects to a Cisco switch, this Cisco switch, it's going to use VLAN 127. In the FortiGate that is managing my FortiSwitches, I go to the VDOM, and there's my model config. And in this process, it's the same. I go to manufacturing logical network, and I choose VLAN 127. So Cisco switch, FortiSwitch, the screen looks a little different, but the concept is the same. In this process, then, I have the ports configured in the case of the FortiGate. So this switch port and several of the switch ports in this device are assigned the role-based access group. So I have the FortiSwitch 224 in the role-based access membership group, so that that feature is enabled. And on the Cisco, I have the same thing. All of the ports on this Cisco are in the role-based access group. That allows me to apply the policies for the network access configurations that we just showed earlier. So that means that when I connect pull it out of the FortiSwitch, plug it back into the Cisco, we notice that the device will show up automatically, and we will put it into the appropriate VLAN. Now, part of the process of developing this policy was discovering the NAC policies for the different types of devices. So I have the discovery of the device itself, I have the process to do the device profiling, I have the NAC policy, and I have some controls and membership set on the switch. Now, what do I need to do to actually configure the switch to be controlled by FortiNAC? First part of it is we gave the credentials to FortiNAC for this switch. So SNMP settings, and then the CLI settings as well. So I can SNMP into the switch, and I can control the switch through CLI. And then the other part is the configuration of the switch. If I look at this, I have a very simple configuration to fully manage the switch. I have the VLANs. This is the manufacturing VLAN. I have the MAC notification traps enabled on each port. That's all I need. So a simple int range, configure all of the interfaces on this switch. They're all the same configuration. There's nothing special per port. And then where do I send that information to? Well, I'm sending all traps to the IP address of my FortiNAC system. In addition, I have 2 global configurations for the MAC address notification as well. All of that allows me to receive a MAC trap when the device connects into the system and change the ports effectively. Now on the FortiGate, we have that set up a little bit differently, just using some additional features that we have available. On the FortiGate, that's managing those FortiSwitches. On the FortiSwitch ports, I have the port that I have set up for the device, and I'm going to plug that into the FortiSwitch again so we can see it show up on this port. But I have the port set up with a default 802.1x policy. So if I want to look at that policy, I come down to FortiSwitch policies, and we'll see how simple this policy is. Basically, I'm using FortiNAC as the radius server because FortiNAC knows the MAC address of the device, the PLC device, and we'll appropriately answer that radius request coming in, and we're doing MAC authentication bypass. So I have FortiNAC set up as the radius server. I'm sending the MAC address over as soon as it connects into the switch port, and then I'm seeing on the port the device will show up in the appropriate network. When we connect the PLC device back into port 1, you'll notice that we don't actually change the native VLAN in this case. When we do a radius MAC authentication bypass, we're not changing native VLAN, but we are answering the VLAN request and putting that device into VLAN 127. So I see the MAC address, I see its IP address, I see it's in the manufacturing network, even though the native VLAN says 1. So that's just something to note when you're using .1x instead of VLAN switching. And again, the configuration is very simple by applying the .1x policy with MAC authentication bypass on the switch. Those things all allow us to find all of the PLC devices in our network. We can assign them the appropriate value. Wherever I plug this device into a Cisco switch or a FortiSwitch like I showed in the network, an HP device, a Dell device, a Juniper, we're going to change that VLAN access value either through MAC notification traps, through 802.1x requests, and we'll make sure that wherever you connect that PLC device, it's always in the right network access value, the right VLAN for your network. All of this has tracking for audits, and we can show the numbers of devices in the different parts of the network through multiple methods. So in this case, I have a filter for PLC devices in my filter list, and that's how I pick this device and can see it in the system here. So hopefully that helps you understand how simple it is to write a policy, to apply it to a PCL device, that's on a Cisco switch or a Fortinet switch using MAC notification traps or 802.1x. So any questions, email jreed01 fortinet.com and I'll answer your questions for you. Thank you.